Alright class, so let's take a look at a couple gear train problems. So it says the diagram shows a gear train composed of 3 gears. Gear A revolves at 60 revolutions per minute in a clockwise direction. What is the output in revolutions per minute at gear C? So I'm going to jump right into this problem and I'm going to write down the formulas we've seen before. We have gear ratio equals number of teeth out divided by number of teeth in equals diameter out over diameter in, which is also equal to angular velocity in over angular velocity out, which is equal to torque out divided by torque in. Well, I got to figure out what I know and don't know. They tell me that A is 20 teeth, B is 60 teeth, C is 10 teeth. They also let me know that A is 60 revolutions per minute. So I got to first remember what out and in mean. It's output, which is the part that they leave out, and inputs. So the output gear, as mentioned previously, is the one that's going to be at the end of the gear train. So this is a simple gear train. This is the effort is being placed at A. So this is where I'm providing my input, and the output is here. And as previously mentioned, this is an idler gear. So now we could actually start this problem because to start off, we're just going to go ahead and plug and chug and see where we go from there. So given the fact that we know the teeth of A and C, we can at least solve for gear ratio. So let's go ahead and do that. So the gear ratio is equal to number of teeth out divided by number of teeth in. So the output is 10 teeth. I'm just plugging in right what it tells me. And input is 20 teeth. So I'm going to reduce that. The teeth cancel out. 10 divided by 2. I'm going to write that as a ratio of 1 to 2. So my gear ratio is 1 to 2. Now if gear ratio is 1 to 2 and I have the revolutions per minute, but I'm trying to solve for the revolutions per minute of gear C, then I know I have to use this formula. Well, if these two are equal as well, now I can say that 1/2 is equal to angular velocity in over angular velocity out. Because I can already know that the angular velocity in is 60 RPM divided by an unknown out, well, I only have one variable I need to solve for, and that's the revolutions out. So I'm going to cross multiply. That's going to give me W out is equal to, so W out times 1, 2 times 60, 120 revolutions per minute. Alright, great. Just so you guys know, in case I needed to do something like the torque or anything like that, I would, again, knowing the gear ratio of 1 to 2, I would set that equal to the torque. I would have to at least be given one of these torque, either the torque out or torque in, and I can solve for the unknown. Same with diameter. If I'm given one of these two and I know a gear ratio, then I can solve for the one unknown left. Now let's take a look at the second one. So let's take a look at this one. This is a compound gear, I know, because I have 2 gears on the same axle. The way we think of compound gears, it's a combination of more than one simple gear train. So I see A and B is one simple gear train, C and D is another. So it's 2 levels worth of simple gears on top of each other. It could be as many layers as possible, but a compound gear is more than one simple gear stacked on top of each other at one axle location. So it says, what is the output in revolutions per minute at D? So output in RPM at D. Big things. What is the direction, and what is the direction of rotation if gear A rotates in a clockwise direction at 30 revolutions per minute? Alright, so let's start with the first part. That's really the equation part that I'm going to focus on. Again, they can tell us a couple things. Gear A is 120 teeth, gear B 40 teeth, gear C 80 teeth, gear D 20 teeth. The way I'm going to handle a compound gear is like 2 individual simple gears. So how many individual simple gear trains do I have? Well, I have one layer on the top, which is AB, and a second layer below, which is CD. So why don't we treat them part by part? First, let me solve for the gear ratio of AB. Well, the input, and the one that's spinning to start off, the input is going to be gear A. So input, and that's delivering the power to B. So we're going to call that the output. If that's the case, the gear ratio, I'm going to go ahead and use the number of teeth, which is given. I'm going to say the number of teeth out, which is B, is 40 teeth, divided by number of teeth in, 120 teeth. Teeth cancel out, and I'm left with 1 of 3. Now that's equivalently equal to my angular velocity. So if I look at that, then that's going to tell me that gear B, so let me think about this. Gear A is the in, so the input of A in RPM is 30 RPM. And we don't know the angular velocity of the output. We cross multiply, and we solve that the angular velocity out, or we'll go ahead and say of B, is equal to 90 RPM. All right. So that's going to be important for us. Why? Because if B and C are on the same axle, then the angular velocity of B has to be the same as the angular velocity of C. They're on the same axle. So it's like putting two wheels on the same axle and then spinning the axle. It doesn't matter whether you have one small wheel or one big wheel. They're both spinning at the same number of revolutions per minute. So now I know the angular velocity of gear C. But that's not the question. They want to know the angular velocity of D. So in order to figure that out, now I'm going to have to verify the gear ratio of C to D. So now I'm going to focus on that second gear train. So gear ratio of C to D is equal to gear out. Well, now C is the one providing the input, and D is the one along for the ride, the driven. So output is 20 teeth divided by the input, which is 80 teeth. I get 1 of 4. Now I'm going to use the same formula and plug and chug. Do I know the input? Well, I do, because now the input is going to be C. It's not A anymore. Now I'm focused on input because I'm down to the second simple gear. So the input is going to be the 90 RPM divided by what we don't know, cross multiply. Angular output at D is equal to 90 times 4, 360 RPM. So from starting at 30 revolutions per minute, we went all the way to 360 revolutions per minute, and that's my answer. That's the angular velocity of the output at D. If we want to answer the second question, we could look at that quickly. If this goes clockwise, then B, it's always going to go opposite. It's going to go counterclockwise. Since B and C are in the same axle, then it's also going to spin in the same direction, which means D is going to spin in the opposite, which is clockwise. So D will spin clockwise. So I would say the angular velocity at gear D, the output is equal to 360 revolutions per minute clockwise. Okay, and those are the two problems. Hope you learned something from them. Make sure to watch the other videos on gear ratios so you understand the basics of the terminology. All right, thanks.